Endpoint security, huh? And application developments. Things that need to be done. So we just want to talk this time around about different threat intel sources, what you must go through to secure an endpoint, and how to create dev ops that includes security, or SecDevOps, which is that same thing except backwards, basically. And what DevOps is, if that's a new one on you. Hopefully not. It's a thing. So, what is threat intelligence? Should probably be the question we answer first, right? So, I mean, you may be familiar with threats, like bad guys doing bad things, and intelligence, knowing about that stuff. Many sources share that information amongst a number of different organizations. So sometimes that happens within the context of an individual like industry. There'll be organizations that share within, say, the retail industry or the marketing industry or the grocery store industry or the furniture making industry for some that are more around here. So there will be things like evidence of what happened in an attack, or KRIs, or key risk indicators, that explain like what went on inside of these attacks. Those are the things like, was there a bunch of network activity per second, or was there a bunch of failed logins? Is there an attack using, X amount of bandwidth, or a bunch of email leaving your system? We tend to call, if there's some kind of risk indicator that's out of bounds, or a number of other things, indicators of compromise, or IOCs. Basically, an indicator of compromise indicates that you were compromised, right? So it shows that there's some kind of malicious activity going on somewhere that may be sort of in the early stages of attack, ideally, so that you can, fix it before it gets too bad, catch the bad guys on their way in, and help figure out beforehand that somebody is trying to get in. So if you see a bunch of failed login attempts on a server somewhere, it is probably not unreasonable to think that there is some sort of attack underway. So that would indicate that a compromise is imminent, or that somebody is trying to do so. Seeing that somebody had logged into a server that wasn't supposed to would indicate that the compromise had already happened. So OSINT, or open source intelligence, is one type of threat intel that you can get your hands on. So anything that you can find, out there on the internet comprises OSINT. Sometimes open source threat intelligence is a separate category on itself. OSINT, you'll also see that term thrown around when you're talking about types of intelligence about targets, if you're an attacker or a red team. So they'll find, people's LinkedIn profiles in an organization, or all this stuff that you can find on the internet about organizations is also another form of OSINT. Your favorite CISCP, or CSIP, is going around and providing actionable, relevant, and timely unclassified information exchange. So those are the kind of organizations that will trade industry-wide, or analyst techniques that they outlist here. The procedures they're using to go through and analyze information. And then that shared information across industries, and shared between industries. So if banking's got something going on, then the grocery people might benefit from that. Can happen through CSIP conversion, and doing malware analysis, which is not like super easy to do organization by organization. It's not, Meyer doesn't really have the need to have a full-time malware analyst on hand. So doing it across organizations or being able to dip into the expertise of specialists is important in those kind of things. There is a lot of concern about doing that stuff publicly because potentially, if you're an organization that was attacked, you don't necessarily really want to tell people what was going on. So while providing it, sharing indicators of compromise with someone, you could potentially be teaching folks about like the vulnerabilities in your organization, which you don't want to do. So, telling them about how the attack happened, that's not great. You might be letting them know like we didn't change the passwords on our SSH servers or something. So if you have an automated system, some sort of automated information sharing, that might spill the beans on that sort of thing, right? While it's nice to have that information updated in real time or very quickly, you need to make sure that is going out to only folks who you trust. So there's a couple of tools that can help you do that. The structured threat information expression language is a way to exchange those IOCs and all of that stuff automatically using a formalized language to do it. And trusted automated exchange of information intelligence is another protocol for doing that over secured web traffic, or HTTPS, the hypertext transfer protocol secure, to let your, that cyber threat intelligence is the cute buzzword we use here, to get that around. And then closed source information is proprietary stuff that may be disclosed within a small group of private information sharing centers that you need to be on the guest list to get into. So if you want to be a member of some of the local organizations that work with the FBI, that may involve having a background check done in order to make sure you're secure, or that you are in fact a member of the industry that you're working with, and not just letting any Joe in off the street who alleges to be interested in that sort of thing. So there's a bunch of useful threat intel out there in things like vulnerability databases that are, a repo of what's been going on and what's been exploited out there. Such as the NIST National Vulnerability Database, for example, that has all sorts of CVSS reports in there. So these are the things currently that are going on and are a big deal. The last 20 vulnerability identifier IDs, and then what they were. And a useful resource to have in your back pocket. And others along that line. Threat maps, like that one, these live cyber threat maps, I sometimes consider them to be more of they're kind of a marketing tool for the antivirus and firewall companies that run them. There's a bunch of them out there. The folks at Zone H want you to log in before you get to them, but Kaspersky runs one. And basically they'll tell you where they're getting their data sources from. Fortinet's got one. The digital attack map here, it's crushing my computer to run all of those. But they sort of kind of give you an idea of what is going on in the world right now, because they give you a list of these are the things that are happening on the network, and this is what's blowing up right now, and this is the attacks that we're seeing in real time based on our product, or at least close to real time on their products. It looks like right now in the United States, There's a lot of this going on. And they'll give you statistics about it. So, I mean, kind of a way to like show off what's going on. They try and show the geography. So I guess potentially they're useful for figuring out what kind of stuff is, attacking your neck of the woods right this second, even though maybe a little cheesy. Could be, possibly. File and code repos out there, repositories, if you will, that include all of the info about places that people have uploaded stuff. I am thinking mostly of VirusTotal would be the big one. Although, not the only one. But VirusTotal allows a user to go in and upload a file that could potentially contain malicious code. I wonder if I have any malicious code I can upload to VirusTotal. It's the kind of thing I sometimes have lying around, like you do. Everybody does. But it will take either the file itself, or it will take the hash of a file and let you search for it. Or if you have a website URL that you think is, particularly suspect, you can upload it there and see what they think. And based on whether or not they have seen that in the past, they will tell you. Furthermore, they'll let you know if some other tools detect that as a piece of malware. So I think I might have written some malware for this class. Let's see. Or what will have happened is my computer will have gone through and deleted all of the malware, thinking it had detected a problem. I had some in my temp folder here. Temp hacks. This is sounding legitimate. All right, signed hacks 2. So I upload this file. Looks like 2 folks have already figured out that it's malicious, probably by some of the behavior in it. But these are all the different antiviruses that are using that. So those guys are an example of a file or a code repository. Another one that's fun to play around with is run.any. And or any.run, backwards. These guys will let you execute malicious malware and run it on a virtual machine and tell you what happens. So these are a list of the submitters. These are the public tasks that have been found, and most recently there was a xhacks zip uploaded, and the reason it's interactive is you can see what happened on this system to be malicious. Apparently it would not execute ehacks because it steals credentials from browsers, steals credentials, and gives you an idea what's going on. So those are a way to go through and see what other attacks have been out there. And then finally, the dark web, where essentially when we say dark web, we just mean stuff on the internet that hasn't been Googled, and potentially the Tor network, maybe. But there are services that specifically keep an eye on the dark web in order to make sure you kind of know what's going on inside of the dark web. So that's threat intel. This is not a terrible breakdown of what we mean when we say the dark web, right? So if it's on Google or Bing or Yahoo, that's not the dark web. You might call the deep web the places where you have to have a it's like a subscription service in order to use, and then the illegal stuff hiding out on the Tor network, that's the deep dark web. And actually that I I don't know, that might be upside down, because the amount of stuff that is not available is that deep web stuff that doesn't get indexed. So if you ever get access to like a big academic library, there's all kinds of information in this world that hasn't been out there. So endpoint computers are the things that we think about when we like sit down in a cubicle, right? Or that the laptop that Bill takes home. Sometimes endpoint devices are broadened out to include things like the the tablet in your purse or the phone in your pocket. So all of those things can potentially benefit from having themselves at least secured by making sure that it is secure from the giddy up, protecting it while it's in use, and then hardening the operating system as it goes along. If you took the A+ course, you probably had to memorize all this stuff about UEFI, or the Unified Extensible Firmware Interface, which replaced the older basic input-output system, the BIOS, or Basic Input Output System, BIOS, of a computer. It's what starts when you push the power button on a regular computer. And there's usually an analogous mechanism for things that aren't like traditional computers. Phones have a similar mechanism. Like Samsung has a thing called Knox. Apple doesn't like to publish details about how it works, but every now and then their iOS gets broken into. Cisco iOS, the Internet Operating System on Cisco devices, which, by the way, they license those 3 letters to Apple so they can have an iOS too, has a similar bootloader system. What UEFI does that's different is when it is starting to boot up, the part that is beyond what the BIOS does is giving you access to bigger things, letting you have bunches of hard drives, booting faster. But the important part for us is that it also can confirm integrity. It also like gives you a more robust interface when you're booting up a system. So for the gamers out there, you've set up your own computer, you've probably seen a boot up system like this. Back in the olden days, you couldn't use a mouse to get around in a BIOS, and now there's like mouse support and all that kind of fun stuff. The reason we care about it in security, though, is that now the ability to secure the system booting up is integrated into that. So once upon a time, like if you had a BIOS that you traditionally would upgrade, if somebody tampered with the file that was that BIOS, now they've got like as low a level a hook into the computer as you could ask for. So what we would prefer to do is have security in that, verifying that each step in the boot process, starting with like you flip on the switch and this very low level part of your computer loads up, is as we think it is and how it, pardon me, and that it has not been modified. So the way that works is the boot software is initially verified, and they do that through cryptographic signing, and then it validates the low-level operating system that loads up, and the pieces that load the device drivers and so on and so forth, causing what is a chain of trust as the BIOS loads the low-level operating system, loads the drivers in the operating system, and at each step, they're verifying that that has been cryptographically signed by a trusted party. Now, if one of those trusted parties screw up, Microsoft recently cryptographically signed a device driver that was malicious and sends data back to China. It works great. And if it doesn't, you get problems. But hardware is difficult to modify. So a hardware root of trust exists on computers that says only allow software that has been cryptographically signed by Microsoft to run, which works great right up until Microsoft cryptographically signs a device driver that is invalid. So these things are not without their problems. Your endpoints can be protected in a number of ways that we will discuss here. Everybody's probably most familiar with antivirus software, and many of us have been led to believe that like we throw that on our computer and ta-da, we're secure. But your AV generally, like depending on the the quality of your antivirus, sometimes it's a whole suite of things, including firewalls, including anti-malware that we'll talk about here in a sec. Um, will generally, like in its simplest, will look for files on a system and look for things creating documents, and then compare them to a known bad list and looking for signatures, so cryptographic hashes of files, and looking for like badness that they've seen previously. Which, if you go to one of the reasons that most of the cybersecurity professionals I have asked this question of, which is actually kind of a lot, and most of the folks in cybersecurity don't really buy into like fancy antiviruses, is because either you will wind up with a couple of products that get out ahead and find malware, even malware that some professor wrote for some class somewhere, and detect it because they're being like overly aggressive, and those will be the products that wind up with false positives, or within hours of antivirus being sampled in the wild, just about everybody will have it. Everybody will have the malware figured out, and that'll be that. And so the like benefit of having some fancy AV product is usually not much better than just using whatever your operating system has. So free advice, worth what you paid for it, is probably like, if you're using Windows, Windows Defender is probably as good of antivirus as you're going to need. Dynamic analysis or heuristic analysis is like the next step in that. And most products do some form of this these days, which is basically just looking at the heuristic or the sort of stereotyping of the way viruses and malware work, right? And if it sees something like the way viruses work, then it's bad and it's going to fire it up. So there are next gen AV products that are using AI and ML to figure out what's going on there. Anti-malware is when you broaden that out to look for multiple types of malware. Mark loves Bayesian filtering, so he throws that in to every one of his books. But by looking at email and word frequency, you can compare a pile of spam to a non-pile of spam. Same thing's true of most types of web pages, and those products might involve things that integrate into your web browsers to prevent like pop-ups or automatically loading JavaScript or bad things like that. But there are things you can put into your web browsers unto themselves, and like they're constantly getting better and better and better. Some of those cross-site request forgery, cross-site scripting attacks depend on the ability to have one website from a different origin than the one you're on, and they prevent against that. Keeping connections on the network secure using HTTPS means that no one can look at the contents of things, including the cookies that you might send across the interwebs. That way that cookie can't, especially if it's your identity, can't be used for getting into trouble. There was a big kerfuffle over a product called Firesheep. That was a little sort of hacking tool that would catch unencrypted session cookies. So a session cookie is that I'm logged into MySpace. You know, this is a big deal. It launched when like 2010. So maybe I was early Facebook, late MySpace. And you could, if you captured that session cookie, you could then pretend to be me if that wasn't secured. So it is a thing that happened. Those response headers on websites can help keep that down too. Then to protect your, so like also block ads on your web browsers. Would be security advice there. Ad block of some sort. uBlock Origin's my go-to. You can also monitor those things. You have a host-based intrusion detection system. So that's an intrusion detection system that lives on a computer endpoint that will potentially notice when an attack is occurring. Detecting versus preventing is when prevention systems can potentially get you into trouble. Their goal is to immediately start blocking things, which means you can potentially use those to trick computers into blocking stuff maybe they shouldn't block. The new hotness these days is EDR, or endpoint detection and response. Those generally are integrated into more robust systems that might include not only the stuff from the EDR tool, but from other tools that you have in your like network defense arsenal. So these tend to be enterprise level systems. And then we'll be able to detect anomalies and analysis. Some of the stuff that's currently like new and exciting are things like behavioral analytics. So they, in addition to keeping track of the computer, they keep track that Joe in marketing only logs in between the hours of 9 to 5. And if that account logs in after 5 p.m. or at 3 a.m. on a Sunday, that there's a problem. So that's protecting them. Hardening them, I've talked about the CIS, I guess we're at top 18 these days, defenses, and it includes these things, right? Going through and making sure that you've got patch management going on and set up your operating systems appropriately. Every second Tuesday of the month, Microsoft and a number of other vendors now drop their patches for their operating systems and products. Usually you want some sort of, in an enterprise environment, you want some sort of service that takes care of that for you. In a home environment, Microsoft has pretty much automated it away for you. Usually you want to have updates forced. There are, for Windows 10, you catch those patches. There are selective updates, so like things that are optional. And it is nice that Windows 10 also does things like, if you have an organization that doesn't have a really robust patch management system, it will do things like peer-to-peer share the patches amongst the Windows 10 systems. This ticks off my network intrusion detection system that I run at home all the time. But it is kind of nice that you download it once and then those computers share it, the updates in their free time, essentially. So we looked at configuration guides for securing operating systems. That's going to be turn off all the stuff you don't use. Of course, step one is going to be know the stuff that you have on your system to begin with. Know that you have a system you need to organize. Disable or change default accounts and passwords. All of that kind of is the principle of least functionality and the principle of least privilege. So let people do as little as they need to do their jobs. Let people have access to as little functionality as they need to effectively use their jobs. And that's where like IT, security, and users start having friction, because the opinion of what it is someone needs to do their job varies pretty broadly, particularly between the IT person who never does their job and the person who actually does their job. That's when the fun starts. So Windows has a bunch of tools, including security templates that you can create a template and it will apply to all the systems you apply it to. You can distribute that through things like a Microsoft Active Directory that will let policies be applied to individual systems. You've also got the Windows security settings that can be prevented, that won't let you change them. Again, applying those through, this is the local group policy editor that we have in this screenshot here that's set to not allow users to have access to registry editing tools, which in sort of a meta analysis, local group policy editor does have the ability to modify that. So you won't be able to run that on there anymore. And then you'll get a chance to look at some of these, the different containment tools that can either restrict what malware has access to, includes application allow and deny lists, is the more inclusive way to say whitelisting and blacklisting, but that go through and say, these are the applications that we let work. These are the applications that we don't let work. So by applying a allow list, you can say things like, you're only allowed to run programs cryptographically signed by Microsoft, which oftentimes is successful, or you're only allowed to run programs that are signed, period, or signed by the following vendors. You also have the ability to sandbox applications inside of Windows and other operating systems that will prevent them from getting out. Chroot is a utility that's been in Unix since the olden days that tricks an application into thinking that it only has access to or that forces an application to only have access to certain parts of the file system, and then quarantining files that Windows thinks is suspicious is a thing you can do. There's a whole suite of these. They're not quite hacking tools, but every time I download them onto a new computer, Windows Defender flips out and is like, these are potentially unwanted programs. This is potentially a hack tool. I'm like, yeah, dude, that's what I do for a living. So this is how operating systems interact with the applications that they're running and the files that they're running. Down here is sort of the ring zero stuff, the stuff that is the operating system low level things. And up here is what we might call user space, where the operating system is running applications for the system. And without hardening, potentially applications can all talk to the same file system and potentially get up to shenanigans there, potentially work in the same memory space on the operating system and potentially get into shenanigans there if one of those applications is malicious. So a nice idea is that you can put them into their own little sandbox where application one can't mess with the files and settings that we don't allow and can't mess with the memory of other applications because it's locked into that its own little space. And again, there's equivalents for that in other operating systems, in Windows and Linux and Mac OS and all of those other things. So those are endpoints. That's how we harden them. So to talk about DevSecOps, we probably should talk about DevOps, SecDevOps, DevSecOps. The development team is usually the dev part of DevSecOps and or SecDevOps. The ops team is the operations side of that. And you used to have developers that were kind of in their own little cloud, and then the rest of the IT department that managed the day-to-day functioning of the network and the applications and the systems online. And then you would have security as a separate entity that was out there somewhere in the IT department, basically shouting into the void saying, guys, this is not secure, don't do that. So the thing is that applications sort of live in the intersection of all of those spaces. So there are applications that can use things like a directory traversal attack, where if you've ever managed to bounce around your Windows system, or any operating system really, you might have noticed that, here's my hacks directory, where I was putting that last piece of naughtiness, that if you do ... as a directory, that you move to the directory in the folder above where you're currently at, into the temp directory in my case here, because I was in the hacks directory previously, or if I'm in the dist directory and I go into the ... directory, I will go back up to the hacks directory. Sometimes that's called directory traversal, and it's occasionally, depending on how an application is built, an avenue for attack, a directory traversal attack. So it's a security thing that involves the application itself and the operational side of the computer. So if you can push files around, I could potentially push an evil file into a place where the operating system runs the file a lot and force it to do a thing I don't want it to do. So you can potentially, I could potentially view confidential files that way. I could potentially inject commands that way. If you recall back to the OWASP top 18, I guess it was, top 10 from 2018. Command injection is number one on that list. And then beyond that, there's all the sort of buffer overflow, integer overflow, memory problems that you can potentially have. Object dereferencing, there's a whole list of potentially bad attacks that can flow from that. And this is that directory traversal thing, right? If this is c:\inetpub /www root / or it would be /news. If I've got an application or a dumb web server as Microsoft's Internet Explorer, which was inetpub, they could go to www root would be like webserver.com/news. And then if I went to news / ... that would take me back to the www root folder /... would take me back to the inet pub folder /... would take me back to the C drive /windows takes me in here, and then /system32. You get the idea. And now I can potentially, just by using a web browser to look at a web page, be poking around inside of the contents of the system32 directory, which is where all the goodies that make Windows run live, or the, C:\/ secret documents that I don't want anybody to look at. Now that is generally a solved problem in modern web servers, but every now and then you'll find either an application or a poorly written web app or a poorly written interpreter. So like something that you feed data into and make it do a thing that is still subject to that like 1990s style hack right there. So if you find yourself in the application development space, and many of you will, since we make this a requirement in our programming curriculum, you need to think about concepts that involve security that you might not previously have considered, especially when you get into like the sort of continuous integration and continuous deployment or development, CDCI or CICD or whatever they break down the acronym as, where you're taking the development of the application and then testing and then staging the application and then dropping it into production all in one quick go. Nowadays, many development teams are using Scrum, which is this continuous process of developing, testing, staging, deploying, developing, testing, staging, deploying, or putting into production is another way to say deploying, that pumps that out. And so that would sort of be the DevOps approach to things. Putting the sec into DevOps involves making sure the security is integrated into that at each of those stages, ideally. At least before it gets to staging and production, please. If you're implementing the concept of software diversity in your shop, that's building basically duplicate variants of the program developed by different teams, so that you can compare the results of what they come up with, and ideally find bugs where you would not otherwise, come up with better, more reliable systems, and ideally come up with increased documentation, which every programmer loves to do. Every coder I've ever met got in there because they wanted to write documentation. So that's a lie. It's not true at all. So inside of a network, you need to provision things for systems, for any IT resource. Somebody has to provision you a printer if you want to print from your desk, and someone has to figure out how all of that business gets managed. And then when you quit, they have to de-provision all of those things. Or when a project comes to an end, like we needed a server for the XYZ project, and now the XYZ project's over, take that server down. So those processes need to be in place. And if you remember the CIS list of things, like managing your stuff is at the top of the list. Making sure that we can attest to who has those systems and that they're only doing what we think they're supposed to be doing is a way we can measure integrity of a system. So those are general concepts. That model I was talking about, where we iterate over and over and over again on a project, is generally the modern approach to both software development and project management. It is usually a incremental approach as opposed to the old sort of waterfall model, where the waterfall model works on what many of us youngsters like to think of as a failed premise, which is like, we will use this model, this sequential design process, to come up with a perfect product the first time, which generally doesn't happen. Agile sort of takes it as read that there's going to be problems and just tries to get as much of a product out the door as we can, and then fix it and fix it and fix it, which leads to its own problems. See Cyberpunk 2077 for details. But that's the various types of application development life cycles, or project life cycles, if you're talking about a whole project, that involve creating a thing and pushing it out the door. DevSecOps integrates security into that so that you're making the best use of those processes in order to further the goals of security, right? We're going to take this agile process or this waterfall process and integrate into it as much security as we can. So a lot of that we would like to be automated. So we would like it, our application continuously monitored by a system. So to make sure that it is doing what we think it should do, validated so that it in fact does that, integrated, meaning it is set up and ready to like connect to all the systems it connects to, delivered to where it is going to be put out, and then deployed so that users are using it. So that's kind of the broad overview of applications. In terms of secure coding, that involves the process that we are trying so hard to teach our young programmers to integrate into the process of writing software, right? So we want people to create secure applications, and then we want those applications as restricted, again, principle of least privilege and functionality, so that when they are attacked or if they are defeated, that they can't expose more than they should. So a big part of that will be determining how we encrypt and protect our data. And for this point in the course, it's sufficient to know that encryption just means that there's a secret key, and without that secret key, you can't get to it. And then making sure that all of those memory vulnerabilities we're talking about we are defended against, right? You can't introduce these memory vulnerabilities. And there's a bunch of ways to do that. That might, it's definitely going to include testing of one sort of another. There's a bunch of different flavors of testing. Ideally, when we're implementing and verifying our software, these things will happen. We will have some testing that looks at the static code, so code not running, right? Just reading the source code and looking at what's going on there, and then finding common mistakes that are using things. Like there is a deadly, poorly written, in my opinion, C functionality you can use called strcpy that will just copy strings into a memory address and dump it right in there. So static code analysis should say, oh, that's strcpy. That's dumb. Use a different function to move your strings around, please. And there are better ones out there. Dynamic code analysis is going to look at the code while it's alive, right? While it's doing its thing. So we're going to look at that as the application is running and as it's getting done, whatever it is our application does, in order to figure that out. That may involve a technique called fuzzing, whereby we provide random data into the places we're allowed to provide input to the program. So in the login box of our web application, we might try throwing all kinds of different data at it and see what happens. And that would be fuzzing the application. This is the output of some automated system that is user abrascar scratch foo.m, where there is in here a divide by zero error that the automated static analysis tool discovered. So that's kind of what it will get to. And this is a fuzzer that the Peach Fuzz Bang that is taking this template and creating a fuzzed PNG to feed it using some selected strategy to create input for an application, presumably that does something with images, to try and trick it, to try and blow it up, to try and make it do something bad. And there was, speaking of images and media files, anytime you take user input, even if it's user input as sort of complicated, especially taking user input that's complicated like a video file or like a image file, potentially it can cause those memory corruption kind of problems we were talking about, or a whole host of other problems. And I was thinking the Android stage fright bug and associated bugs existed because Android was taking input from videos and causing all kinds of problems. And those common vulnerabilities that we find in our database of repositories of vulnerabilities. Like, notice there's like a ton of these based on the way that Android was unpacking in particular MMS, text messages with pictures and stuff in them. And like, don't fear, iOS has its share of those as well. But those are the kind of things that a fuzzer hopes to find before it gets into the hands of the users and really causes us some trouble. So there you have it. Everything you ever wanted to know about AppSec, but were afraid to ask. So sharing information, CVEs, and other IOCs and other TLAs. TLA is a 3-letter acronym. The computer industry is a huge fan of that. Vulnerability databases, very good. Threat maps, they're nice for marketing. They look pretty, don't they? And then file and code repositories, definitely good source of threat intel. Securing your endpoints, just make sure it's booting up without bad things in place. It's a good place to start. We're big fans of AV, although the AV that comes with your operating system is probably everything you ever needed and more. Don't tell McAfee or Norton that, but that's the truth. It probably does all the things just fine. Web browsers are getting better and better at security, although they're basically the computer of our age, so they're what's being attacked. A HIDS, or host-based intrusion detection system, as compared with a NIDS, a network intrusion detection system, is usually software that runs on an endpoint, looks for attacks while they're happening. Securing your computers, make sure they're patched. That's definitely true for home users. You don't want to be the person who doesn't have the patch for yesterday's 0-day vulnerability that's now today's 1-day vulnerability. Those applications can potentially compromise even the securest OS, because applications are given at least the enough user privilege to do what they want to do on a system. And then you're going to do a lot of testing if you're doing the DevSecOps correctly. That's